Hey guys, so hope you had a great weekend. What we're going to be doing today is going through the last part of the lesson that we started last week, which was lesson 6.2, 6.3, and 6.4. So we got all the way up to right before irregular figures. So I'm going to walk you through the lesson on irregular figures, and then you'll have an assignment to complete on Schoology tonight. What we're going to first start out with, though, is just a quick refresher on the different area formulas we talked about before. So you have the area of a square, which we said could be sides squared because both of these sides here are the same length. Or you could do just base times height. And then you have the area of the rectangle, which we said could also be base times height, or it could be considered length times width. And I have that wrong. So whichever ones you want to use, no matter what, you're still going to get the same result for either formula. Now, the next one we did was a parallelogram, and a parallelogram's area is also base times height. Now, remember the height comes from a perpendicular segment from the top down to the bottom, okay? And these sides right here, they're not the bases. These are just sides of your parallelogram, okay? They're really no relevance to the formula. Area of a triangle is simply just 1/2 base times height because it's half of a parallelogram. So you have to do, or remember I said you guys could do area is equal to base times height divided by 2, whichever one you're most comfortable with. And then finally you had area of a trapezoid where you have to add your bases together times by your height and then multiply by 1/2, or what you could do is height times base 1 plus base 2 all divided by 2. Either one is the same thing. And again, your height comes from a perpendicular segment from your bases down. And remember, we just use B sub 1 and B sub 2 to represent our bases. It doesn't matter what order you plug it in when you plug it into the formula. So what we're going to do today is we're first just going to start out by finding the area of some figures. So for the first one here, you're going to want to identify what your shape is. Well, I know it's a square, so I have to use the formula A is equal to side squared. And then plug in what I know. So my side is 10, so I'm going to do 10 squared. Well, 10 squared is the same thing as saying 10 times 10, which gives me 100. So my area is equal to 100. However, I am not done yet because I need to ensure I include my units. And in this case, I had centimeters, so that means my units are centimeters squared. So I'm going to come over now to this rectangle. I know area of a rectangle is equal to length times width. Well, my length is 8. My width is 3. That means my area is 24 using your units, yards, squared. Alright, jumping down to the triangle now. So, remember, you need area is equal to 1/2 base times height. Now, the base here is going to be 12. Your height is making that perpendicular segment from a vertex down to the other side, or your base. So that means my height is going to be 4. So doing the math, I know half of 12 is 6. So now I just have 6 times 4, which is 24. Now, no units are given, but I still have to label it with units, so I'm simply going to just say units squared. Alright, and then jumping over to my last one here, the trapezoid, I'm going to use area is equal to, and I'll do height times base 1 plus base 2, all divided by 2. So I'm going to fill in what I know. I have a height of 10. My bases, again, it doesn't matter what order you plug it in, just plug them in and then follow your order of ops. So I have to do 16 plus 9, which gives me 25, all divided by 2. So now I have to do 10 times 25, which is 250 divided by 2. And then 250 divided by 2 gives me 125. And then units, feet squared. Alright. So that's just a quick refresher on using our formulas in order to be able to solve. These are the same figure, so we're just going to skip over that. So now what we're going to do is get into irregular figures. So area of irregular figures, all it simply is made up of multiple polygons. So an irregular figure is just a makeup of multiple polygons. So steps to follow when finding the area of an irregular figure is simply to divide the irregular figure into individual figures that you know. So what I mean by that is figures that you know how to solve the area for. And then what you're going to do is you're going to add all of the areas together to get the total area of the irregular figure. So if I look at this example here, I could divide this a few different ways. So I could simply divide it going down like that, meaning now I have this figure right here and then this one right there. I could also do it another way. So I could take it and I could simply just go like that, and I'd have this top figure now and then this bottom figure. Okay? Some of you might even choose to divide it into 3 figures, meaning you'll go down like that and then you could go across like that. So now you have 3 figures that you're going to work with. It doesn't matter. You're going to get the same total area no matter how many ways you divide this up. One person might do one way and one person might do another way. So don't be alarmed if your friend does it differently, or if I do it differently. You can simply divide it all different ways. But again, you're going to use the area formulas we have talked about so far. Alright, so let's get into an example. So we're going to find the area of the irregular figure. So first and foremost is you want to divide it into figures. Okay, so you want to divide into figures that you're comfortable with being able to solve with. So for me, I'm going to draw in some vertical lines. So I'm going to go straight up and down right here. And then I'm going to also put one in going this way. So now I have 3 figures. So here's the first one. The second one's in the middle here. And then the third one. One thing for you guys to know is that it didn't upload right, but this segment right here is supposed to be 4 centimeters. So with that now, what we're going to do is we actually need to solve for the area of each individual figure. So your second step is to solve for area of each figure. So what we're going to do now is, if you notice, I decided to write what number each one of these shapes is going to be. Okay, meaning I need to solve for the area of 3 shapes. So when I'm doing it, I'm going to just write a 1. I'm going to write what the formula is. So area is equal to, well, if I look at the shape, it's a rectangle. So I'm going to use A is equal to length times width, and then I'm going to fill in what I know. So I have 6 times 4, which gives me 24. So now I'm going to solve for the area of my second figure. And that is going to be area is equal to, looking at it, it's a rectangle, so I'm going to have length times width again. So in this case, it's going to be 5 times 4, which gives me 20. And then I have my final figure, which is figure 3, which again is another rectangle, so it's length times width, which gives me 9 times 4, which is 36. Now, I am not done because that's the area of each individual figure. It's not the area of the total irregular figure. So step 3 is to find the total area. So in order to do that, what you're going to have to do is add up each one of these 3 areas in order to get that. So your last step is to find the total area, which is going to be equal to 24 plus 20 plus 36. Well, 24 plus 20 is 44. 44 plus 36 gives me 80. And then you need to include units. So this is 80 centimeters and its area, so 80 centimeters squared. So it's important for you guys to remember that you need to take each one of your irregular figures, divide it into different figures that you're comfortable with finding the area for. You then find the area of each of those figures, and then you add up all your areas to get the total area of the irregular figure. All right. So we're going to move on to the next example. So again, start out by dividing it into separate figures. Now, some people might choose to go one way and some people might choose to go another way. Like some people might go down like this, over like that, and then down again. Or some people are just going to keep it really simple, like myself, and I'm just going to notice I have a rectangle and I have a triangle. So I have figure 1 and I have figure 2. So I first need to find the area of figure 1. Well, it's a triangle, so I'm going to do 1/2 base times height. So that becomes 1/2 the base. So that is something I'm going to have to solve for. But if I notice, this segment here is 1. This segment here is 2. The full length of my rectangle is 8. Well, if I take 1 away from 8, I'm left with 7. And if I take 2 away from 7, I'm left with 5. Meaning the length of this segment right here of my triangle is going to be equal to 5 centimeters. So my base is 5. The height is also 5. So now I'll keep going with that. I now have 1/2 times 25. And then half of 25 is 12.5. So that's figure 1. I'm now going to solve for figure 2. So for figure 2, I notice it's a rectangle, so I'm going to have to do length times width. The length is 8. The width is 5. 8 times 5 gives me 40. Now I have to remember, I'm not done yet because I need to find the total area. So to find the total area, what you're going to have to do is you're going to have to take 12.5 and add it to 40. Well, if I take 12.5 and add it to 40, I get 52.5 centimeters squared. And that's your final answer. Okay, so you're going to flip over to the back now of your note sheets, and there's 4 U-Try problems for you guys to do. Pause the video right now and then come back and check your work. So pause the video. So this one was kind of already divided for you, so I'm going to just have figure 1, figure 2, figure 3, figure 4, and then finally figure 5. So there's the area for the first U-Try problem. If you notice, figure 4, so this triangle down here, is the same dimension as this one up here, so I just wrote same as 2, so no need to do the work twice. So example 2 then. So the area for figure 1 is pretty easy, but once you get to area of the figure 2, of how I divided it, you're going to notice you have this full length right here of 12, but this little part here you're not quite sure of. However, you have these other 2 little pieces right here of both being 3. Well, if your full length is 12, taking 3 from that gives me 9. Taking another 3 gives me 6. That's how I get that part to be 6. Same thing goes with the width. This full segment down here is 15. This part is 10. Well, what do I need in order to give me 15 to represent that part? And that's how I got the 5. And there you have it. Your total area for this irregular figure is 111 meters squared. So if you're still struggling or need any help with this, please reach out to me. I'd be happy to help you. But what you guys are going to do today is you're going to complete all of the problems on both sides of the worksheet that's posted for you guys. It needs to be completed by Tuesday night at 11:59. Again, if you have any questions, please reach out. Other than that, have a great day, guys.